guys, welcome back. This is Krishna and welcome to my YouTube channel. So we were talking about deep learning. In that, I will demonstrate you the syllabus, like how we will proceed in this tutorial. So there was few topics I mentioned in the previous video. If you haven't go through the previous video, please go through it first and you will understand what I'm talking about. So in this video, I will show you neural network, okay, like a feed forward neural network I will create, and I will show you what kind of parameter we have to use to train a model. So there I need first of all the data set, then I have to pre-process the data set, load the data set, and then I have to scale the data set. All right. So such kind of thing I have to do. I already have multiple data set in a library called sklearn, which I used in machine learning tutorial. So if you don't know about sklearn, please go through my machine learning video. If you need the playlist link, you can go through the description of this video and you'll get the playlist of machine learning. Okay. So simply go there and you will understand about sklearn. Okay. Now I am going to create the neural network. Okay. The feed forward neural network. All right. And I will show you what kind of parameters I'm going to use there. So let's go to Google Colab sheet for now. All right, guys. So this is our very first concept, feed forward neural network. Okay. In this, I mentioned 5 points. The first one is load pre-processed data. So first I have to load the data set, but from where? I have to first import a library called sklearn. So step 1, I'm going to demonstrate here, which is load and pre-process the data set. All right. So in this, I have to first import the important library. So from sklearn dot data sets. So data sets is a kind of a module we have inside sklearn package. I will import breast cancer data set. So breast cancer data set is there. Okay. After that, I will import some other library for pre-processing because this is to load the data set. Now I will import pre-processing tools. So from sklearn pre-processing, import min-max scaler, because I have to scale my data set also between 0 and 1. If you don't know about it, I would recommend you. In machine learning, this is the extended version of machine learning. So if you are not getting any kind of concept here, you will definitely get in machine learning playlists. I would request you to go to machine learning playlist first of all, and then come back here. Okay. Now I will import model selection from sklearn. And from there, I will import train test split because I have to break down data into 2 parts. First for training and second for testing. Then I can only evaluate whether my model is fine or not. So here I'm simply showing you the working of neural network. Okay. I'm not talking about terminologies. I will talk about terminologies in separate videos. Okay. For each concept, I will create a separate video and I will go through the concept thoroughly. So don't worry for that. Now, let's run this. And here I have to first create the data. Okay. So this is that data set class, which is breast cancer data set. This is in the form of class. So I have to create object of this. So I'm saying cancer data set is equal to, and done. Means this cancer data set will give me all the data which is available inside breast cancer kind of class. Okay. So if you will print this, you will get a dictionary. See, this is a dictionary where I have a key called data, which contain our feature, which is available in 2D array. See, we have a 2 bracket starting point, 2 bracket and end. Okay. So this is a key and its key value is this data. Okay. Which is feature. And this is my target. Target means that data basically tells about, this data basically tells about whether a person is cancer infected or not. If a person is cancer infected, that means in front of that person data, like this is the data of a person, let's say, okay, he is cancer infected or not infected. So because this is in at a first index, see, Let me give you one demonstration, what I'm talking about. So let's talk something like this. Let's say this is my first sample, which is this. Okay. So whether this person is cancer infected or not means this whole data will appear here. Okay. And whether he is cancer infected or not, I have to check. So this data is on 0th index inside this array, this outer array, right? This whole data is at 0 index with respect to this outer square bracket. Okay. So this is on 0th index. Similarly, here I have target array where this is the one dimension array, and in this I have, and in this I have on 0th index, on 0th index I have what? A value called 0. That means 0 means a person is not infected with cancer. With cancer. See, some places it is mentioned 1 like this places. Okay. So here that means the person who's lying in this data at these position, these index position, definitely have cancer or suffering from cancer. So this is the only data it is talking about. Okay. So here we have two kind of patient available. First, who has cancer, and second, who doesn't have cancer. So such kind of data set we are talking about. So here we have two class or two classes, you can say. First, a person is either not infected with cancer or infected with cancer. So 0 means not infected with cancer, and 1 means infected with cancer. So I'm talking about this data set. This is the whole description about this data set only. So let's move ahead and do some coding on this. I just gave you the illustration of this data. So now we split the feature inside a variable called x. Okay. And again, split the target into the variable y. Okay. This is my feature x and this is my target y. So that means the value, which is data, the key of this dictionary, will contain the whole feature, okay, into x, and the target, which is this one, this is the target, the whole array. So this will comes inside another variable called y. Okay. So such kind of array we have. So first of all, I'm going to get the data. So I stored this variable inside a cancer data set, and I have to mention here data. Okay. So once I will mention data, I will get all the features. See, I'm getting all the features. Why I'm not getting all the features here? It's already there, but because of 3 dots, it's hidden. Okay. It is a kind of technique of Google Colab Sheet or Jupyter. Okay. So don't bother about this kind of 3 dots. Okay. Which is also available in here. Okay. So don't get bothered with this. This is nothing, but it's a type of data demonstration by Jupyter Lab or Google Colab Sheet. I'm just storing it inside a variable called x because this is feature. Okay. This is feature, and feature stored inside x. Okay. So if you will run this, the whole data gets stored inside x. If you want to see the data again, you have to simply mention x inside a print function, and you can see all the data. All right. Now, if I want to get single sample of the whole array, I can simply mention x square bracket 0. Okay, because this is on 0th index. This whole list or array, you can say vector, it's at 0 index, and that's why I'm mentioning 0 here. Okay. So if I will mention x0 and I will hit shift enter, I will get all data of this very first vector. This is that vector. And inside this vector, I have like 1.79 here, 1.79 e plus 0, 1, right? 1.799 e plus 0, 1. This is nothing but e exponent we are talking about, and its power is 1, okay? Means 10 to the power 1, okay? We are talking e means 10, multiply, like it's something look like this. See, if I will expand this, it is something look like this, 1799 into 10 to the power 1. So this e plus 0, 1 means this, okay? Similarly, here we have e plus 0, 1, e plus 0, 2, e plus 0, 3. So if anybody will ask you show this in expanded form, so you have to simply show it like this, e to the power 3, or this e value is 10, okay? So you are simply mentioning 10 to the power 3. So this is the actual value what is mentioning here, right? So there in this very first feature vector, we have 30 feature column. How many feature column? 30 feature or features column, okay? 30 features column. So generally it has 30 features, okay? If you want to count, you can count it. Let's say this is the first, this is second, this is third, this is fourth, this is fifth, sixth, and how many rows are there? 1, 2, 3, 4, 5. So 6 into 5, how many features we have? 30. So in each sample there are 30 features, okay? And on the basis of this 30 feature, generally we are determining whether the person is a cancer positive or negative. So the very first person was cancer negative, that means 0, okay, which is available in our data set on 0th index, because here we this value is also on 0th index, and inside the target vector this is also available on 0th index. That's why this is 0, means this person is not cancer infected, okay? So let me show you the next topic. I just demonstrate you just to show whether what kind of data I'm getting on 0th index in feature, okay? Similarly, I want to show you the target. So target I stored in y, right? Above I stored it inside a variable. Oh, I didn't stored it. So target I will store inside y. So again, I have to say cancer data set dot target, because inside the data set we have target key, okay? Because that's a dictionary, and I will simply run this. I will get 1D array where I'm getting 0, 1, 1, a lot of numbers, right? So there are only two classes, 0 and 1, okay? That means whether a person is cancer positive or cancer negative. So if he's a cancer negative, that means 0. If he is a cancer positive patient, that is 1, okay? So I'm storing this value inside a variable called y, and this is my target stored inside a variable called y, okay? So now I will go with this data only. So if I want to see the very first patient, whether he is a cancer positive or cancer negative, I have to simply mention y square bracket 0. It will simply return me 0, because on 0th index, see, I want to show you. If I will print y here, so on 0th index, there should be small y. If I will print y here on 0th index, I will get 0. See, if this is a array, 1D array, okay, so on 0th index, what I'm getting? 0. So simply here when I'm calling this y and 0, it is simply giving me 0, okay? Because on 0th index, I have a value called 0. See, here suppose I'm indexing the all value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Some sort of indexing we do always. So on 0th index, it is 0, and that's why what I'm getting 0. So the very first person, in this sample, this, okay, is a cancer negative patient. See, on feature we have on 0th index this particular person who has 30 feature column, and he is cancer negative, okay? So such kind of data it is talking about, okay? Now let's pre-process it. So first I have to break down into two parts. Break down data into two parts. First part is training data set, and second part is testing data set. Okay, so training data set and testing data set, we have to split it. Why? See, I'm going to create a model, right? I'm going to create a model, a deep learning model. Okay, so not only deep learning, even in machine learning we have to follow the same process. Okay, in machine learning model also, okay, we have to follow same process. What we have to do, we have to simply split data into training and testing. Why? Because first of all, I will provide this data to my model. Suppose this is my model. Okay, I want to pass this data set to my model to get trained. Okay, to get inside the data and create some pattern, so model get trained. This is only happened behind the scene. So model basically nothing but an algorithm who try to get some pattern from the data which we provide to a model. Okay, so the data which I will provide to this model, it will simply find some pattern. Okay, and on the basis of pattern, my data will able to differentiate whether a person is a cancer positive or cancer negative in future, once I will train this model. Okay, on the basis of 30 parameter which we have passed in the feature sample. Okay, so after training, I have to also test whether this model is working fine or not. And for that, I need testing data. Testing data means whatever data I have available. Let's say I have 100 samples. Okay, I have data of 100%. Okay, so if I want to train my model, I will, let's say, use 80 data samples to train my model, and remaining 20 data sample I will keep to test my model after training, whether my model is working fine or not. How can I test? I have to test with some unseen data which model didn't see before, right? So I will pass this 20 samples to my model, because this my model never seen this data before. So once I will pass this to my model and ask, tell me what should be the output, positive or negative, then my model give me some output like whether this 20 samples are positive or negative. So I will check what kind of accuracy it is giving, it is properly trained or not, or there is required some more data to train it. So I have to go through. So that's why we basically split our training testing samples into two parts. Okay, I already explained these things in machine learning playlist also. Now how can I do this? So I have to split X or my feature into two parts, X train and X test. So X train and X test. Okay, see, this is my feature. Okay, there are many samples. Okay, many samples. Let's say I have 5 samples. Okay, for now let's say 5 samples inside this X. So I want to break this data into two parts. Okay, so I want to store it in X train and X test. Okay, and I want to break this data in two ratios. First, I want to break it into 80-20 ratio. Means suppose my data samples are 5. Okay, so I want to break this 5 data samples into 80-20 ratio. Means 80% of this 5 sample would be 4, and 20% of this 5 sample would be 1. Okay, so first 4 values will store inside this, and the second will store inside this one sample. But it can be a random value also. It is basically a random value, because if we will not make it random, the model will be biased. Maybe it will give you the user specific output. Suppose I want to get only positive, so I can manipulate my model. So that's why I have to use random concept. Means randomly I will pick 4 samples. So in that case, what happened, whether this or this will come in our very first X train, and this will go to my X test. So it happened. You don't have to do anything for this. You have to simply call a function called train test split. You have to simply call a function called train test split. Okay. So let's call this X train X test. Similarly, I will break down the Y, which is target. So I will mention Y train Y test. All right. And I have to call the function which is train test split. I have to pass here X and Y. X is my feature, Y is my target. This will help you to get the random value and split the data into two parts. Okay. Now you can also mention train size. So there is a keyword argument. Okay, so train side, I want to keep it 80%. So I have to mention something like this 0.8. I cannot mention 80%. Okay, it is in machine learning or deep learning, we have to use some sort of numbers. 100% denoted by 1. Okay, 1.0, and 80% denoted by 0.8. If you want to mention 90%, you have to mention something like 0.9. Okay, so 0.8 I'm mentioning here, and it will give you random value each and every time. X train. Okay, so if you will print this X train, see, initially I was getting 1.799 on 0th index, but after breaking down into two parts, I again print it. See, I'm not getting the actual value what I was getting previously on X. See, I'm also printing the X. Okay, see, on X, the very first sample has this data, but when I break it down into two parts, in X train and X test, I'm not getting exact value which is mentioned here. I'm not getting exact value which is mentioned here in this X train, because there is some randomness happened because of X train test split kind of function. Okay, so these things you have to keep in mind. To protect our model to become biased, we have to implement such kind of strategy, and this strategy implemented by train test split itself. Okay, so no need to bother about it. Okay, so if somebody will ask you, what if I will run this again? If I will run this again, then this will again get changed. Okay, see, right now I'm getting 1.894. Let me run this set. 1.141. See, it get changed. So what happened? So basically this is called randomness. Each time the data get changed, it's a sequence get changed, it's randomly pick 80% of the data from existing data of X. Okay, so what can we do to make it static? I can simply pass a random state. Let's say you can mention any value. It's a kind of a, you can say, pointer. Okay, pointer in C++, it simply denote our address. So let's say I'm mentioning 1. That means now whatever output will come, that will be intact as it is. See, 1.799 I'm getting. Okay, so 1.799 I'm getting. If I will run this cell again and I will run this X train again, it will not get changed. See, I'm getting the same value, no changes. Okay, because this simply indicating a address like a pointer. Okay, if you don't know about pointer, just go through the Google. Pointer is nothing but it's a store the address of another variable. Okay, so that is called pointer. It introduced in C++. Okay, now I have my feature and target. This is my X train. Okay, now I would like to see the shape. So this is an array. I can mention X train dot shape, and there are 455 we have samples. Okay, so now you guys will ask me what about the rest data? So that rest data gets stored inside test X test. Okay, so how can we check that? X test dot shape I have to mention. So first of all, we have to check how many data were there inside X. Okay, so X was our original data, original feature. Okay, and how many samples are there? X dot shape I have to mention here, and see here I'm getting 569 data samples. Okay, this first value is row and this is column. Okay, I already told you there are 30 feature in each sample. Okay, and that's why we're getting 30 everywhere. See, I'm getting 30 here as well, right? So I will get this 30 everywhere because there are 30 columns or 30 feature columns we have inside our data set. But it is 455 means 455 sample it is talking about. There are 455 rows or samples. It simply uh, contain X train, and the remaining 114 samples it contained by X test. Okay. So if you will add this to 455 and 114, you will get 569. You want to check? Just check. 455 plus 114. If you will run this, you will get 569. See? So the whole data of X gets split into two parts, X train and X test. Okay. Now I want to show you the target also. So this is the target. Let me run this first. So see guys, this is the target of this sample. Okay, this is Y train is the target of X train. Okay, whereas X test target is Y test. Okay, which I will show you right away. Okay, so let's see. Okay, let me show you the shape of this also, so you will betterly able to figure it out. See, it is one dimension array, so it has only one value inside the tuple. 455 samples. So Y train is the target of X train. So here we have 455 rows. Okay, 455 samples. So their target will be also equal to 455, and that's why we are getting 455, right? Whereas here in this sequence, we are getting X test where we have 114 samples, right? So what should be the target of this? So Y test dot shape, if I will show you 114 target. Okay, 114 target like X test. Okay, so X test has 114 samples, so its target is also equal to 114. Okay, so this is how I split the data into 4 different variables, and I told you what are the use of each. Okay, so this is the feature, this is the training data set, okay, using which I will train my model, and this is their target, okay, of X train. Okay, so let me show you. This is X train, this is Y train. These, this is this is called feature, and this is called target. These two I will use to train a model. Okay, and these two, let me pick another color, and these two, this is a test feature, and this is a test target. Okay, so this thing I will use to evaluate my model, whether my model is working fine or not. To evaluate this, I will use these data. Okay, so this is the description about how we will implement pre-process and break down the data into two parts. Now I have to scale the data also. Why scaling is required, I will let you know about it. So scaling the data set. Okay, so I already import min max scaler on the top. Okay, see, I already import min max scaler. See, from sklearn pre-processing min max scaler I used. Okay, so I imported min max scaler. Min max scaler is also a class, so I have to create object of this first, and this is my object. Now sc dot fit underscore transform. Okay, so first of all I want to show you. Okay, so what will happen after this? I have to pass my X train. Okay, so once I will run this, I will get all values between 0 and 1. Okay, inside all column, let's say if I will mention this data into print, let me store it X SC, X train SC, because I convert train data into scaled value now. Okay, and if I will print X train SC, I will get these values. Okay, now here if you will see each and every column, this is my first column. Let me change the marker color. If I will use this first column, this second column, third column, and many columns are there inside this 3 dot. Okay, this is 28th column, 29, and this is 30th column. Okay, this is 30th column, 29th, 28th. This is first column, this is second column, this is third column, and remaining column inside this 3 dots. Okay, so here it simply convert my whole data set between 0 and 1. Okay, all columns get converted into 0 and 1. These all columns get converted between 0 and 1. So min max is scalar basically reduce the size of each column and their samples or their features in between 0 and 1. Okay, so that's why min max scalar is important. I already told about this in machine learning playlist, like how can we do this, what kind of procedure we follow, but don't worry, in this tutorial I will also teach you about this. Okay, because this is a broad concept. There are 5-6 scalar we have, so I have to create 5-6 videos for each scalar. Okay, so don't worry, don't get bothered. For now, just focus like we are scaling to train our model properly, otherwise it will not get trained properly. This is how I basically scaled my X train. Now I want to scale my X test also. This is my X test. Okay, I want to scale it between 0 and 1. Right now it is not between 0 and 1. So what I can do, I have to simply use sc dot. Now don't use fit underscore transform, simply use transform. Okay, why is transform I'm using? Because whatever scale is being used by this min max scalar to make this whole column scale between 0 and 1, the same column will implement on this X test if we will use transform. If we will use fit underscore transform, it will again generate new scale, so the relation between the data get changed. Okay, so to make it relatable to each other, we have to use transform. So whatever scale here used to scale these feature, the same scale is also used, the same scale will also used by the model sc to scale this whole column. Okay, so let me run this and I will store it X test and I will print X test. All right, and see, I'm also getting scaled data here. Okay, now one important thing, we never scale our target. Keep in mind, we never scale our target. If you are going to scale your target, it will definitely give you error. Okay, so never scale your target, keep in mind always. So note, we only scale features, not target. Keep in mind, this is a note for you all guys. Okay, so keep this thing in mind. Now from here we finished our first task. So our first task was load a data set and pre-process the data set. Okay, so what we did, we simply load the data set breast cancer data set. Okay, which is available already inside sklearn dataset module, and then I extract feature from the data set which I already imported, breast cancer data set. Okay, breast cancer data set, what I have imported from there, I extract a feature which is stored inside a dictionary key which is called data. Right, this is data and this is their feature. Now the third part is I extract a target. Okay, I extract a target from cancer data set. So there is also one more keyword which is target, which stored this target vector. Okay, so I stored this target vector and I extract it and store it inside a variable called y. Okay, after that I check the shape. After that I break it down into train test split. means the whole X and Y, I break them into train test split with a trainable size, which is 80%, means 80% of overall data I will use for model training and 20% for model evaluation. Okay. After that, I scale the data to specify each and every column feature into a specified range, okay, which is 0 and 1. So these operation I did here in the very first step. Now, the second step we have is create a feed forward neural network model using TensorFlow and Keras. Okay. So let's go to implement second model. So I'm simply mentioning here a heading like this, and I have to create the model. So to create the model, I have to first import important libraries, which is import TensorFlow as TF. Second one is from TensorFlow.keras.models import sequential. Okay. From the third one is from TensorFlow.keras, then layers import dense. Okay. Then we have to import TensorFlow.keras.optimizers import Adam. Okay, there are multiple optimizers. So these are the model which we'll use in our model training. So I'm going to create the model. So model.sequential, I have to call the sequential which I have imported. I have to pass a square bracket. Okay. Inside this square bracket, I have to pass my model's parameter. So what kind of a parameter I have to pass? So first I have to mention the input layer and first hidden layer. Okay. So first of all, I have to define this. Okay. So how can I do this? So I have to mention dense, and let's say I need 32 neurons initially, let's say. Okay. After that, I have to pass input shape. Now input shape is 30 because my each sample has 30 features. Okay. My each sample has 30 feature. You can see here. Okay. So this is my first sample, and inside this sample, I have 30 features. So input shape is 30, right? Means if this is my neural network, let's say. So here in the very first layer, this is called input layer. Okay. This input layer has 30 neurons. Okay. So this input layer has 30 neurons. Why 30 neurons? Because in our each sample, I have 30 feature column, 30 features column. Okay. And that's why I need 30 neuron in the input layer. Okay. With this only, this is my input shape where I will pass 30. Okay. And this is 32. This is my first hidden layer. Now I have 32 additional neuron on the very first layer. This is my first hidden layer. Okay. This is my first hidden layer. Okay. So in this line, I mentioned two things. First, the input layer, which I will just gonna define it. 1 second. Let me define this. X train dot shape, let's say I passed. So not X train dot shape, X0 train 0, and I have to pass shape. It is not complicated. Okay. You can mention instead of this like a 30 comma. Okay, this is also workable. Okay, just to make it dynamic means in future if somebody will change my sample, let's say in that case, what will happen? So to make it dynamic, I'm simply passing here X train. I import very first feature, and very first feature has 30 samples, right? 30 feature columns. So to get that, I have to simply mention shape here. So once I will show you to printing this value, let me create one more shell here. If I will run this, I will get 30. See, I'm getting 30. So basically, I am passing this 30 here. Okay, this is my input shape. Okay, most of the people get confused like, what is my input shape? Because these two mentioned in the very first layer itself. That's why many people get confused. And this is our first hidden layer, 32. It is talking about the neurons. Means this is that first hidden layer where we have 32 neurons. Okay. After that, now I have to pass one more parameter here, that is activation, because in first hidden layer neurons made up of two parts. First one is offline, that is y is equal to mx plus c, and the second one is activation. Okay, so I have to mention activation part here. Activation is equal to, let's say I'm mentioning ReLU here. I will tell you about it later on in this tutorial. Again, I have to pass one more, let's say layer. I'm mentioning here 100 neurons, and I don't have to mention input size now, because whatever output get generate once we will pass the data. Okay, once we will pass the data, okay, of each, okay, some sort of dense network it's created. So whatever output it will generate, let's say A1 is the output, will become input of next layer. Okay, so if I am mentioning, let's say 100 neurons here, so this will become input of this second layer. Okay, A1 become input of second layer, because A1 is the output of all calculated values. I will explain this thing also, don't worry. So let me show you that. I don't have to mention input now, input shape, because initially we define input shape. And I have to mention like 100 neurons I required on second layer, and activation will be ReLU again. Okay, and at output layer I need one neurons only. So dense is equal to 1 comma activation. I am using sigmoid here, sigmoid, because in my model there are only two classes. So sigmoid basically used to classify between two classes. Okay, so sigmoid I'm using here. Now I have to compile my model. I'm basically teaching you about how a neural network look like. I'm not explaining about the terminologies. Okay, so don't get panic, like I'm not telling you each and everything thoroughly, because if I will start teaching you each and everything thoroughly in the same video, this video will become of 10 hours. Okay, so I don't want to do that for now. I just want to show you the demonstration, like how neural network get trained, how neural network we can code first of all. So compile my model. The next step is to compile our model. This operation is called create a model. Means from here to here, I'm simply creating my model, like how my model will look like. Okay, now I have to compile my model. So compile my model, like how can I compile it? So I have to use model.compile. See, I'm getting compiled here. And inside this, few parameter I have to pass. First of all, I have to use optimizer. So Adam I will use here, and I will pass learning rate is equal to 0.001. Then I will mention loss, and loss I will mention binary cross entropy. And then I have to mention matrices, which is accuracy. accuracy. After that, I have to train the model. So what I have to do, model dot fit, I have to fit it like machine learning models. So I have to fit it first, and I will pass here X train, the X train X test I created initially, X train, Y train I have to pass for model training, and I have to mention epochs. Epochs, let's say 50. I will teach you every terminologies, okay? Don't get panic. Epochs, and then I will mention batch size. Batch size, let's say 50 I'm creating, and the testing data which I split it called validation split, validation split, okay? There I have to mention 0.2 because while splitting the data, I splitted 80% of data into training. I splitted 80% of data in training. Let me show you. 80% of data in training. So remaining data are 20%. So that's go in validation. Okay. Like my model is working fine or not to get that. Okay. So for validation split, I have to mention 0.2. Now, if I will run this model, let me clean the window. Now, if I will run this model, my model start training itself. See, I'm getting training. Okay. And this way my model get trained. Okay, so it is giving me accuracy like 90%. Okay, see, it start improving from start. Okay, so what is epoch, what is loss, what is accuracy? We heard about loss before, we heard about accuracy before, but validation loss we heard about it, but this time I use different terminologies, validation loss, okay, and validation accuracy. So I will explain you about this. Okay, so basically when we train our model, we try to get accuracy, right? So here, because of back propagation terminology, which I haven't introduced so far, I will introduce in next video. So this is the accuracy. This is accuracy column. We will focus on this. See, my accuracy increases each and every time. Okay. See, 80%, 85%, 80, 86%, 84%, 80%, 87%, 85, 88, 90, 89, 90, 90, 90, 93, 91, 48, 89, 29. And see, at final stage, I'm getting 91.48% of accuracy I'm getting over here. So 91.48%. We will read like this. Okay. And the loss is 28.91%. Okay. So loss is higher right now, and accuracy is lower. Loss is very high, means we cannot go or deploy such kind of model whose loss is 28.91%. Okay, and accuracy is also very low. Okay, we consider those kind of models accuracy is more than 95% or 96%. Okay, so this is not acceptable, but this is just to show you how my model basically get trained in deep learning. So this is the hierarchy. First, we have to create a model. Second, we have to compile the model. Third, we have trained the model. And we will start getting such kind of back propagation, epoch, such kind of stuff. Okay, this is my validation, like on testing data, how it act. So loss is higher. Let's go to the last line. Okay, this is last line. So see here, while training the model, I'm getting loss 23.21%. 23.21%. We will read like this. Okay, here 100% means 1. See, this is, we will read like 23.21%. This thing we will read like 90.93%. This we will read like 20.09%. This we will read like 92.31%. So what does that mean? Here, while training my model on training data set, I'm getting 23.21% of loss. Okay. But in testing, I'm getting lower loss. So on testing, model is working good. Okay, because there is less loss, so there is minimum loss as compared to training loss. So that's why my model is working good on testing data. Okay, now accuracy is 90.93% here. Okay, and here it is 92.31. so here accuracy is also low, but in testing accuracy is high. Okay, so this kind of model is not acceptable, where training is not well and testing is showing the best data. Okay, so such kind of model is also not acceptable in the market. So I would request you to not deploy such kind of model. And for terminologies which I have used here, I will explain you each and everything in the whole playlist one by one, because it is not possible to demonstrate or to mention each and every topic in the same video, and that's why I cannot do this. So try and understand this. I will explain each and every term, but not in the same video. This is just a base on which we will start learning, like what is layers, what is optimizer, what is Adam, what is activation function, what is ReLU, what is sigmoid, what is a binary cross entropy, what is accuracy, what is learning rate. I will teach you everything. But for these things, I need separate video. So this is just to show you the foundation of model, like how we create a model. So guys, hope you like this video. If you really like this channel, please do like, share, subscribe, share with your friend families, and give me a thumbs up. If you need anything, you can comment me in the comment section. Thank you guys. Thank you very much.